In this video, we're going to begin our discussion with rational exponents. So, I want to take a look at the square root of 4. So we know the square root of 4 is 2. Now I'm going to rewrite this as the square root of 4 to the first. Now, put into the calculator 4 taken to the 1 divided by 2 power. And what do you get? You get 2. Right? The same thing as the square root of 4. Now, the cube root of 27 we know is 3. I can rewrite this as a cube root of 27 taken to the first power. Now, put into your calculator 27 to the 1/3. And what do you get? You get 3 also. The 4th root of 16 I can rewrite as the 4th root of 16 to the first. Well, the 4th root of 16 is 2. What is 16 taken to the 1 divided by 4 power? Well, that is also 2. So you're beginning to see a pattern for this. Notice the fraction here, 1/2. 1 divided by 2. The 1/3 here, 1 divided by 3. The 1/4, 1 divided by 4. So I can rewrite the nth root of b, and that is the same thing as b taken to the 1 divided by n power. So, if n is a positive integer greater than 1, and the nth root of b is a real number, then b taken to the 1 divided by n power is exactly the same thing as the nth root of b. Okay, so let's simplify each expression if possible. So 49 to the 1/2. I can rewrite this as a radical as the square root of 49. And we know the square root of 49 is 7. Now, let's take a look at negative 49 to the 1/2 power. Well, the negative is on the outside, so I can rewrite this as negative. And again, I can rewrite 49 to the 1/2 as a square root of 49, which in this case is negative 7. Now, notice where the negative is here. It's inside the parentheses. So when I rewrite this, the negative is going to go in under the radical. The problem is the square root of negative 81 is not a real number. So it makes a very big difference on whether the negative is inside the parentheses like this example, or if it's outside the parentheses like the previous example. Okay, let's take a look at a couple other examples then. So again, the negative is outside, so I can rewrite this as negative. But because it's to the 1/3, this is going to be the cube root of 8. And the cube root of 8 is 2. So our answer here is negative 2. Notice the negative is inside the parentheses, so this will go under the radical. Again, it's to the 1/3, so it's the cube root of negative 27 x cubed. Well, the cube root of negative 27, that's negative 3. And the cube root of x cubed is x. So our answer here is negative 3x. This particular example is taken to the 1/5. So when I rewrite this, it will be the 5th root of 3x divided by y squared. I can't simplify any further, so I'll leave it like this. Okay, so now let's simplify the following here. Well, 8 taken to the 2/3 power is the same thing as 8 taken to the 1/3 times 2, because 1/3 times 2 is 2/3. Now, I can rewrite this as 8 taken to the 1/3 all squared. Now, the nice part about this is we know what to do with the 1/3 power. That is the same thing as rewriting it as the cube root of 8 and squaring it. Well, the cube root of 8 is 2, and 2 squared is equal to 4. So 8 taken to the 2/3 power is equal to 4. So how can I do this in general? Well, let's take a look at b taken to the m divided by n power. Again, I can rewrite this as b taken to the 1 divided by n times n. That's the same thing as rewriting it like this. And I now know how to write the b taken to the 1 divided by n power. That is this. So, in general then, if m and n are positive integers greater than 1, and the nth root of b is a real number, then this expression can be rewritten as the nth root of b taken to the nth power. Okay, so let's simplify each expression if possible. So let's start with 36 taken to the 3/2 power. So, according to the above expression, I can take what? The square root of 36, because that's what my denominator is, and then I can cube it. Well, the square root of 36 is 6, and 6 cubed is 216. So, 36 taken to the 3/2 power is equal to 216. Okay, let's take a look at the next example. Notice the negative is inside, so I'm going to rewrite this here, which means I can rewrite it as the cube root of negative 64 squared. Well, the cube root of negative 64 is negative 4, and when I take negative 4 and square it, I get an answer of 16. So negative 64 taken to the 2/3 power is equal to 16. Okay, let's take a look at the next example. Now notice the negative is not inside parentheses, so that's going to stay on the outside. So again, I can rewrite this as, I'll leave the negative on the outside, the square root of 9 taken to the 5th power. Well, the square root of 9 is 3, and 3 to the 5th power is 243. So here, my answer is negative 243. Okay, so let's take a look at some other examples with this then. Now notice, again, the negative is inside the parentheses, so this will be under the square root. So I'll rewrite. So that means it's the square root of negative 81 to the 3rd power. But again, the square root of a negative number, this is not a real number. So I can't do anything further right now with this, other than to write the fact that it is not a real number. Okay. Let's take a look at the next example then. Now, this time I have a negative exponent power. Remember, if I have a negative exponent power, that means I need to put it in the denominator. So this is the same thing as 1 divided by 16 taken to the 3/2 power. Well, I can do the same thing I've done prior to. That means that's the square root of 16 taken to the 3rd power. Well, the square root of 16 is 4, and 4 cubed is 64. So notice again, with a negative exponent power, my answer is a fraction, not necessarily a negative number. Okay, one other example. Okay, I have a negative exponent power, so I'm going to rewrite. Now, I will leave the negative out in front. Okay, so I can rewrite this as the 4th root of 81 cubed. Well, the 4th root of 81, that is 3. And 3 cubed is 27. So my answer is negative 1 over 27. Now, my answer is negative because of this negative that's out in front, not because you have a negative exponent power.